All right, number one on test A is going to be on test C. It's also going to be number 21. So if you have test C, go to 21. If you have test A, it's number 1. If you have test B, let me show you what B looks like. B is going to be the same problem, but a different picture. Okay, so this is your picture for B. I'm going to go over this one as well. If you have test D, you're going to have this same picture, and it's going to be your number 10. So D number 10. So if you have a D test, go to 10. If you have a C test, go to 21. Let me start by doing this one right here first. So this is on your A and your C test. B and D, I'll do yours in a second, so just hang tight. Number 1 says, what is the relationship between these two triangles? Well, look at the information they gave us. I would put a tick mark at AE and a tick mark at ED because they're equal. I'd put a tick mark at BE, 2 tick marks there, and 2 on EC because they're equal. And what do we always know about vertical angles? Vertical angles, the theorem says they have to be equal. So what does that tell me about these two triangles? The two triangles have to be congruent. Letter B says, why are they congruent? What postulate tells me they're congruent? And that's SAS. You can see it right there. You've got a side angle and a side. And then it says, how far is it across the lake? The lake is here. So I've got, let's see, 15 paces from A to E. I've got 16 paces from B to E. Do we even need those two numbers? No, not at all. Because what we really need to know is from C to D is 9. Why does that one help me?
Oh my God.
Because that's the corresponding side to AB. Those are the two pieces that are the same. So my answer is 9 paces. It did ask you in feet. Now, I did give it to you if you put 9. You were supposed to convert that to feet because each pace is about 3 feet. So you would do 9 times 3 and get 27 feet. What reason justifies my answer here? Once you show me that these two triangles are congruent from SAS, now all the corresponding parts of these two congruent triangles are congruent. That's how that one works. Now, if you had a B or a D test, this was your picture. D, you're looking at number 10. B, you're still looking at number 1. What is the relationship between these two triangles? Again, they're congruent because you've got this angle is a right angle, so is that one. They're both right angles. This side is 15 feet, this side is 15 feet. These are vertical angles in here in the middle. So why are these two congruent triangles? That's going to be an angle, a side in the middle, and then an angle. It's got to be ASA. You've got to have angle, side, angle for that one. What's the distance across the river? What corresponds to this side right here? 65 corresponds to the X. So that's going to be 65 feet. And then what reason justifies your answer is that all corresponding parts of congruent triangles are congruent. So that was number 1 on A and B, and it was the other numbers on C and D. Okay, number 2. Number 2 is also number 2 on letter B. It's the same exact numbers. And if you're at C, go to number 22. If you're at D, go to number 11. D, your number is 11. C, your number is 22. And all the tests have the same answers on this question. I didn't change any numbers. And this question was a little challenging, especially when you got down to this last one. So let's look at the question right now. It says, Pike Street runs parallel to the creek. So I'm going to make arrows. Parallel lines are going to give me angles that are congruent. You have to know that that's what parallel lines are. The only way they're parallel is that the angles are the same. That's going to be a key point later on. So it says, what do we know about the sides? Not the triangles, not the angles, but the sides. They're proportional. Sides can be proportional. sides can make equal ratios. So the sides are proportional. What do we know about the two triangles? Triangles can be similar to each other. They can be a big one and a small one. So triangles can be the similar. Sides can be proportional. Sides aren't similar. All sides are line. I mean, that's not the case. The sides can be proportional. The triangles can be similar. It means their angles are the same. And why are they similar triangles? What makes two triangles similar? Two A's. We got the A's here, and we got the A's here. So that's your AA postulate. Now, what is the length of the side of the soybean field above Milo's Creek? Now, if these are proportional sides, does that mean I could use a fractions here? I could put 880 over 800 equals x over 950. That would work. I could even put 880 over x equals 800 over 950. That would still work. Either way, you're going to get the answer of 1,045 yards. Okay, so that's going to be D. It's E that really threw you guys off. And I kind of had to chuckle at E because, and I showed you about this earlier, was that this side they tell you is 1320. They give you that right there in the problem. And yet I would say about 80% of you, at least 80% of you, gave me 1,200 down here. Okay, and can that be 1,200? Not looking at the picture, it can't. It's got to be longer than the 1320. So what we have to do is figure out what proportion we can set up to get the 20. This is actually going to be 2,520 down here. What proportion would we set up to get that is what we need to know. And you've got to look at the two triangles. Sorry, the two triangles. 880 is the left side of one triangle. 1320 is the bottom. So this is the left side over the bottom. So on my big triangle, I need the left side over the bottom. What's the left side of my big triangle? The left side of my big triangle. It's 1680. And the bottom is my x. That's what I need. It's the left side over the bottom. That's not going to be 1,200. That'll be 2,520. Okay, so that question was the same on all four tests. All right, let's go to 3. All right. All right, we're going, moving to 3. Now, number 3 is on test C. It's number, hold on, 23. So if you got test C, go to 23. If you got test D, it's number 1. Test D is number 1, and A and B, it's number 3. And you're going to just set up two proportions, or one proportion. It's either 2 over 35 equals x over 147 if you have an A or a C test. A or C test. If you have a B or a D test, it was 2 over 25 equals x over 187. That would be a B or a D test. And if you had the B or D test, the answer was 14.96 or 15 if you rounded it off. And if you had an A or a C test, it was 8.4. So that was your answer, or that was your answer, depending on what test you had. Now, if you look at number 4, A and C are the only tests that have this question. If you have a B or a D test, then you actually have this question instead, and they're the same exact problem. It's number 19 on B or D. Test B and test D, it's number 19. Same concept, same work, same everything, just a different picture. So let me go over this one first. It was number 4, on test A was number 3 on test C. If you got test C, it's number 3. So look at number 3, you'll have the airplane one. Let me show you how this one works. Now you've got to use the 20 degrees and the 70 miles. Here's your law of sines. It's on your test. So you're going to put sine of 20 over 70 equals sine of B over 50. You've got to use this one right here because they gave you this 50, which matches up to the B. You've got to find the B first. And they gave you these two. When you solve this, you get sine of B, and you get 0.2443, I believe, is what you get in your calculator. That's not an angle. Don't move it over and think it's 24 degrees or something. This is what you put into your inverse because you're trying to find an angle. When you put that into your inverse, you're going to get angle B is 14.1 degrees. So this angle down here, we get 14.1 degrees. Now if you add these two and subtract it from 180, you get 145.9 degrees. Okay, so that would be your angle C. This is what it's asking for it in the first answer is what this X would be. So you're going to use the same steps that you did. You're going to do sine of 20 over 70 equals the sine of 145.9 over the X. And this time all you have to do is cross multiply. You don't have to do inverses because you're looking for a side this time. You're actually going to get your answer of 114.7 miles. The second question says how many extra did they fly because they actually flew 120. So they flew 5.3 miles extra. So 114.7 was your first answer and 5.3 was your second answer. Now, if you look at B or D, you should be looking at this problem. You got test B or D, go to number 19. Same exact work. You're going to start with these two. Sine of 38 over 21 equals, and you got to do these two right here. So I'll make this A, B, and C. So it's going to be sine of A over 25. First thing I need to do is find the angle, this angle over here, this angle A. So I'm going to multiply these. I'm going to get inverse sine is 0.7329. And that comes out to be, I want to say 74.1 degrees. Does that sound right?
Wait,
Oh, 47.1, that's what it was.
wait, Mr.
I cross multiplied and I got this decimal. And then I inverse signed and I got this angle. Sine of 38 times 25. And then I divided it by 21. Because these two would multiply, you'd have to divide by 21 to get that by itself. I got that 0.7329. Put that into the inverse sine and you'll get 47.1 degrees. That's going to be this angle right here, 47.1 degrees. Now I can find this bottom angle because I can add these two and subtract it from 180. That's going to give you like 94.9 degrees. And now I can solve for x. So I'm going to do the sine of 38 over 21 again because that doesn't have any decimal. Sine of 38 over 21. And I'm going to do the sine of 94.9 over x. Again, multiply your diagonals. This time you don't do an inverse because you're just solving for the side. And you're going to get 34 miles. So that one it'll round off to 34 miles. Yes?
Oh, I didn't. I don't know how about this, but I got 45 for the least one.
Okay, the only way this one will work is to do the law of sines.
I did about
And the only way it will work is if you use the two that you have. You have to start with those two. And you have to go to these two.
I got 33.9.
All right, we'll look at it later, okay? I'll come back to it after the class or whatever. All right, back to letter A test. You're going to go to number 5 next. So if you've got an A or a B test, it's number 5. If you've got a C test, go to number 14. C is number 14. And if you have a D test, go to 16. D is 16. This one was a nice one simply because I gave you little b, and I gave you little c, and I gave you angle A. So that would match up to this middle formula right there. Little b was 11, little c was 21, and then we do the sine of 35, and then you divide it by 2. And if you did that one, you got 66.2. That was test A or test C. That was your answer. If you had test B, then this was a 16, and your little c was 31, and your sine of 34 degrees over 2, and you got 138.7. So that was your B or D answer, 138.7.
How did you get sine of 34?
Just sine of 34 was the angle that they gave you on the problem, right? Was that the angle they gave you? 34 degrees was in there. Okay, number 6 is number 6 on test B. If you got letter C, go to 11. Test C, go to 11. Test D, go to 23. Test D, go to 23. Okay, this is a one-car garage. You have a span that's 6. Okay, if you had a test B or D, your span was 12. Okay, so it was either 6 or 12. I made it pretty easy. This is going to be half of it. So if your span was 6, these are both 3s. If your span was 12, these are both 6s. Do we remember how to go from a long leg to a short leg in a 30, 60, 90? Divided by radical 3, right? But the shortcut was just divide this by 3. What's 3 divided by 3? 1, and then put a radical 3 next to it, so it's going to be 1 radical 3, or just radical 3. What is 6 divided by 3?
2.
2, and then put a radical 3 next to it, so 2 radical 3 if you had B or D test. How do I go from the short leg right here to my hypotenuse? Double it, right? Just times it by 2. So you got 2 radical 3 if you have test A or C. You have 4 radical 3 if you got test B or D. So how long are the rafters? You'd have either 2 radical 3 or you'd have 4 radical 3. This was like 3.5. This was like 6.9 or 7 if you rounded it off. So those, I allowed the decimals.
Are you allowed decimals?
Yes, I had them.
No, for radical 3, I just put 1.73.
Yes.
And 1.2.
That should have been right on your book. Okay, then you get to the height. The height is radical 3, or it's 2 radical 3, depending on what test you had. So it would have been 1.7, or it would have been about a 3.5. That would be the height up here. And how much taller would it be if it was a 2-car garage? Well, you just double everything, because it's an extra car. So this span would have been twice as long. The height would have been twice as high. So I was hoping you would just put radical 3 here if you had A or C, because I just want you want to know how much higher it would be. It would be another radical 3 higher. If you put 2 radical 3, I gave it to you because you were thinking the whole height. What would the whole height be? You could have had 2 radical 3 or 4 radical 3 for your test B or D with these two answers. So again, 1.7, 3.5, 3.5, or 6.9. Those would have all worked.
Radical 3, radical 3.
Yeah.
What did you
Yep.
do? You doubled what?
You doubled the height.
Oh.
Yeah, this height right here got doubled. Yep.
It's either radical 3 or 2 radical 3, right?
Yep. I took either answer. If your original one was radical 3, if this was radical 3, then 2 radical 3 would be the whole height of the next one. So that would have been there, yeah. All right, let's go to 7. 7 is on test C is number 16. If you have test C, go to 16. If you have test D, go to 14. D is 14, C is 16. A and B are both 7s. This one, you need to do Pythagorean theorem twice. You need to solve for A and you need to solve for B. So you're going to do 27.6 squared plus A squared equals 95.7 squared. That will allow you to solve for little a. Now, if you had test B or D, your numbers are a little different. Put the numbers in that you have on your test. To get little b, you're going to do 27.6 squared plus b squared equals 62.3 squared. And on b and d, put in the numbers that you need to get. You're going to find a and b, and you're going to add them together. So if you have test A, your answer was, or A or C, your answer was 147.5. When you added A plus B together, you got 147.5. If you had test B or test D, you had 153.9. 153.9 if you had B or D. A or C test, you had 147.5.
Why is it 147.9 and not 155.45?
Because these are the two answers right here. You had test D or C, right? So you had this answer. 27.6 was test A and test C. If you had test B or D, you had a different number. All right, number 8, vectors.
Oh, I have.
Okay, let me move this over for a minute, and I'm going to double this so that I can show you the two different versions of the test. This will be for A and C test. This will be for B and D test. On your paper, it's test C. It's number 20 or number 17. So if you have test C, go to 17 right now. You got test D. It's number 2. Test D is number 2. Test C is number 17. It's number 8 on A and B. Okay, so the vector was 2, 2, and it was a terminal point of 5, 8. Okay, the B and D test, it had a 1, 2, and it had a 5, 9. So over 1 and up 2, over 5 and up 9. So those were your two vectors. The first question, letter B, is asking for the magnitude. How long is it? What's the length? You could have done distance formula, or you could have done Pythagorean theorem and made a right triangle. 3 and 6 here, so it would be 3 squared plus 6 squared equals c squared. And you would get 6.7 for the magnitude of your A or C test. This one was over 4 and up 7. So it was 4 squared plus 7 squared equals c squared. And that one you got 8.1 as your magnitude. Now your second vector, vector P, now comes into play. Vector P starts at the same place and goes to 10, 3. So 3, 4, 5, 6, 7, 8, 9, 10, and 3 right here.
Oh.
Now they want to know, what do you get if you add your two vectors? The first vector was a 3, 6 vector. Do you see my right triangle had a 3 and a 6?
Yeah.
So it was a 3, 6 vector. My second one was an 8, 1 vector. I went over 8 and up 1 to get to that vector. So that was an 8, 1 vector. If I added these two together, I'd get 11 and I'd get 7. That was on my A and C test. Your B and D test, this was a 4, 7 vector. The second one is asking you to go from 1, 2 over to, let's see, 9, 4. 2, 3, 4, 5, 6, 7, 8, 9, 4. So you're going to go over 8 and up 2. So over 8 and up 2 for this second vector. That would be your second vector right there. Over 8, up 2. So if you add these two together, you get 12, 9. So 12.9 was your answer to number 8 on test B and B, 8C. 12.9. So 11.7 was the A and the C version. 12.9 was for B and D version. 11.7 was your resultant vector. It's adding the two rises over on here. All right, moving on to number 9. 11.7. 11.7. You added 3 and 8 and 6 and 1. Okay, number 9.
Why did he have to do that?
It's just because there's two different versions of the test. Okay, number 9, we've got C is number 18. And D is number 22. So if you have test D, go to 22. If you have C, go to 18. A and B are both 9. Now, this question was the same answers on all 4 test versions. The only thing that was different was number A. This one asked you for AC. If you had B or D version, it asked you to draw that diagonal. So the diagonal, and it didn't matter in the answers, because either way you've got 2 triangles in both of them. And it's asking you, why are these 2 triangles equal? Well, they gave you the information right there. What did they give you? Angles or sides? Sides. I got all sides. I got AB congruent to CD. I got AD congruent to BC. And a common side is congruent to itself. Reflexive property. So what did they give me in this problem? All 3 sides. You got all S's. That's for all the tests. That's all S's. Now, what reason proves now that this angle has to be congruent to that angle? You're right. Once 2 triangles are congruent, now all of the corresponding parts of those congruent triangles have to be congruent. Once you've shown they're congruent triangles, now all their corresponding pieces are congruent. And what do we call angle B and D in a parallelogram? We call them opposite angles. And we're proving that they are congruent. That was one of the parallelogram, what do you call it? One of the things that are always true about a parallelogram. So it was opposite angles are congruent. All right, number 10. On test C, it's number 19. On test D, it's number 7. So if you have test D, find number 7. A and B, it's number 10. Okay, so test A and C, you've got 16 and 17 are your 2 numbers. Test B and D is 15 and 16. So you look at your test to see what numbers you have. Now it says, what's the circumference of a 16-inch or a 15-inch, depending on what test you have? Do you remember circumference formula? 2 pi r, or pi times diameter. Now, what did they give me in the problem here? Diameter. That's a lot easier. Just do pi times diameter. So do 16 pi or do 15 pi. That's going to be 50.3 if you have A or C. It's going to be 47.1 if you have B or D. That's in inches. So that's your 2 answers for A and C test and B and D test. Now, what's the area of a 16 or 15-inch rim, depending on what test you have? Area, you need the radius, pi r squared. So it's going to be pi times 8 squared is going to give you area. Or it's going to be pi times 7.5 squared. So for test A and C, it's going to be 201.1 square inches. For test B and D, it's 176.7. It just depends on what test you have. A and C test is 201.1, B and D test is 176.7. Letter C, it says in a minute of rotation, a 16-inch rim would cover 40,160 inches. So if you let a car go for a minute, that's how far it traveled right here. They want to know how many times did the wheel go around. And I told you when we were talking about the bicycle tire rolling in the classroom here, you take your length and divide it by your circumference.
Circumference.
So you've got 40,160 divided by the circumference, and it was whatever your first answer was, because that was the circumference. So 50.3, or you could have had 47.1 as your circumference. You take the 40,160 divided by that number. You're going to get 798, or around 800 if you did that test A or C. You're going to get 852 rotations if it was test B or D, or somewhere around 850. And notice how the second one has more rotations because it's a smaller wheel. It's got to go around more times to get as far. So that would be your rotations in a minute. Now, a mile equals this many inches. A mile is 63,360 inches. How many times would a tire rotate in a mile? Either a 17 or a 16. You're going to put your length, 63,360, and divide it by your circumference, which is either 17 pi or 63,360 divided by 16 pi. So you're going to have those two, just do it in your calculator. And this one was 1,260 rotations, rounded off. It was like 1,259 something. And this one was 1187 rounded off. So those are the number of rotations. That was number 10. Let's go to 11. Perfect timing on the clock with number 11. Okay, so I'm going to show you the clock right now. It's kind of at a perfect time because it's at like 2:30. Okay, let me show you what happens here. First, how many degrees are represented by the numbers on any clock? Okay, well, how many degrees in a circle? 360. How many numbers on a clock? 12. Just divide those two. It's going to be a 30-degree angle. That's for all the tests. I forgot to tell you what numbers they are. C, it's number 2. Test C, go to number 2. Test D, it's number 6. D is number 6. A and B, it's 11. Okay, all of them have 30 degrees as the first answer. Now look at the clock right now at 2:30. Where is the small hand? It's between 2 and 3. Okay, so let's think about what would happen if it was 6:30. Okay, so if it was 6:30, because that's what this says right here, and we'll look at 7:30 also because that was the other test. So if it was 6:30, what would the clock look like? You would have a big hand straight down at the 6, right?
Yeah.
Where would your little hand be? It would be halfway between 6 and 7. Just like that's halfway between 2 and 3. So what angle does that make? Half of your 30 degrees. So it's 15 degrees. So that's a 15-degree angle if you have an A or a C test. If you got B or D test, they're talking about 7:30. So what would it be? Oops. If it was 7:30, it would be between 7 and 8. So you'd have 30 degrees plus another 15 degrees. So you'd have 45 degrees. So you'd have your, from this to this angle would be a 45-degree angle. Now let me draw a couple more for this letter C right here. Okay, you've got 5 o'clock. It's 5 o'clock. Here's your 12, your 5. And we want to find this arc from here to here. Because what is the length of the arc formed at 5 o'clock? If you have a different test, then it's 4 o'clock. And we want to know this arc right here, x. Now this one has a radius of 8. This one has a radius of 6. So we want to find out the length of that arc. We're going to use our part over whole equals part over whole formula. So it's going to be the part x over the whole circumference. That would be 2 times pi times 8 equals the part of the degrees. How many degrees is it from 12 to 5? Remember, each number is 30 degrees.
150. There's 530s. So this is 150 over 360, the whole amount. This one for B and D, it was it was x over 2 times pi times 6, and it would be 120 over 360, because 4 30-degree angles would be 120. When you solve this first one, you get 20.9 inches. The second one was 12.6 inches. So that's how long the arc was. Yes? Because this is the entire circumference. Part of the circumference over the whole circumference, part of the degrees over the whole degrees. Part over whole, part over whole. Got to stay consistent on
Length
those.
of the arc.
120 was there's 1, 2, 3, 4 30-degree angles. Each number is 30 degrees. So there's 4 30-degree angles, that's 120.
150, right?
150 is 5 o'clock.
150, right?
The answer was 20.9 if you had A or C. It was 12.6. I don't know, maybe I fixed it. I'll look at it. Okay, number 12. Coming over to number 12 now. If you have test C, it's number 13. If you have test D, it's 21. Test D is 21, C is 13, B is 12. Okay, it says he wants to build a model of his building. We did this one on our study guide. I even gave you the fact that you're using 6-inch styrofoam ball for the sphere. So that means that this diameter is 6 inches. That's going to match up with what number in the field? What number is the building? What's that going to match up to? 50 feet. And you might have had 60 feet and 40 feet if you had B and D test. So I would put 6 inches over 50 feet. And that, or I would have put 6 inches over 60 feet. And then I would have reduced it because that's not a scale factor, it does not reduce. So the best scale factor would have been 3 inches to 25 feet for your A and your C version. Otherwise, your B and D version, it would have been 1 inch to 10 feet. It would have been your best scale factor. Now, you don't want decimals in your scale factor. Some of you even divided these and did 1 to 8.3. I gave it to you, but it's not a correct scale factor. Scale factor doesn't have decimals in it. Yep. 1 out of 10, I reduced the 6 over 60, because this was a 60 down here on the B and the D test. Okay, so you see 1 over 10 if I reduce. Okay, now to get the model's dimensions, you're going to start with 6 inches, because we know that this is going to be 6 inches across. It's a diameter. You just need to find out what the height is. So you would use your scale factor, 3 over 25 equals x out of 30 or x out of 40, depending on what test you had. If you solved it, you'd get 3.6 on your A and C version, and you'd get 6 by 4 on your B and your D version. If you put a 40 on the bottom, you're going to end up with the x equals 4. If you put a 30 on the bottom, x is going to be 3.6. Now, surface area of the model. Not surface area of the building, just of the model. So you're going to take the sphere, 4 times pi times radius squared, and cut it in half. Because you only have the top half of the sphere, the dome. You're going to add to it the cylinder, just the lateral area of the cylinder, not the top and the bottom of the cylinder. So you're going to do the 2 times pi times radius times the height of 3.6, or the height of 4 if you're using a B or a D test. So an A and C test, it was 3.6 here. B or D test, it was a 4. Your answers were, for just B, and somehow I messed this one up, just B by itself was 131.9. A, C, and D all had the same answer. And I believe it was 124.4 or something like that. I think. I'm not 100% on that. Let me see. What was it? Yeah, it was about a 124.4, I believe. Or 124.5 or 6. Okay. Okay, and I will fix that if you want me to.
Did you multiply it by
If it'll make them a difference, you might not make a difference if you're gonna do better on the retake. Yeah, no, I'll fix it later. Bring it up after, I'll fix that.
You multiplied it by 10.25?
Yes, that whole thing, then I add these two together. All right, I'm gonna have to stop there. You'll have to watch the rest of them on the video. So part 2 will start at number 13. Okay, so I'm gonna stop this one now.